All right, guys. After we just saw what went down in our chem lecture hall with our potato gun, we ended up seeing that we were using butane gas from our hairspray, and that was where we were getting our C4H10. That is what butane is. And we were having that react with oxygen, O2. Now, the question is what type of reaction is this? If we recall C's, H's, and O's, hopefully you remember with the rapid burning of oxygen, when we have C's, H's, and O's, or C's and H's, hydrocarbons being burned with rapid oxygen, we have a combustion reaction. Our products then, just like the products that are going through, that are coming out of us every time we are generating energy, the products are CO2 and H2O. So now for our balanced equation, we are looking at C4H10 plus O2 yields CO2 and H2O. Well, at this point, this is going to be our hard problem, because right here, we've got ourselves an odd and even kind of situation because we have oxygen occurring in two terms on the right-hand side. So, looking at our balanced equation. Now, once we have that, what we are looking at is a coefficient ratio. We are looking at a stoichiometric ratio. And there is, and there must be, some kind of stoichiometric explanation for the results that were happening in our reaction. Check this out. If we think about the following recipe, right? We had our potato cannon. We had our little spark igniter, right? That we plugged in the end, right? And our barrel. Now, we threw our Nerf ball in, and if you recall, I sprayed in some of that butane, right? So as I spray some of that butane in, right, and I ignite it, we're going to be looking at the butane, C4H10, interacting with that O2. Now, if we think about this, check out our stoichiometric ratio. We need 2 molecules of butane, C4H10, for every 13 molecules of oxygen. So, how can we explain then the observations that we made with our lab demo? Think about this. With an excess of butane, there is less oxygen, right? So too much butane is going to have too little oxygen, and we are not going to have an ideal reaction. This is why it's kind of tricky, because when you look in the beginning and you think to yourself, oh, he just did it for a couple seconds for the first time and he got a huge reaction. The next time it's going to obviously be crazy if he goes crazier with it, right? Well, if there's a lack of oxygen, right, then that means that oxygen is our limiting reactant or reagent. And we're going to run out. We don't have enough oxygen to actually make that reaction as ideal and perfect as it could be, right? And so the idea is spray too much butane in. If there was a 2 butane molecules to 13 molecules of oxygen ratio to be established in this, then once I flooded the system with too much butane, I took away that golden ratio of 2 to 13 with the butane to oxygen.